Okay, good people, let's continue and show you how to calculate the position of the point of inflation. Now, in calculating the position of the point of inflation, this is where we are going to take a moment. At times, they will tell you where to calculate those positions from. They might say to you, calculate those positions from the from the right hand side or the left hand side. It doesn't matter. Your answer would be the same and the correct one. Now, in this case, I will show you in calculating this position from the left hand side. Now, when calculating bending moment, we said it is plus or minus force multiplied by perpendicular distance. That's the same principle that we'll be using as well here. We will be taking moment at this point. When taking moment at this point, it will be I've taken moment on this point. You do the same procedure as you did with other bending moment. On this line, I'm having a downward force on upward force. That's the question that you need to ask yourself. You're obviously having a downward force, and the value of that force, it is negative 20. It has to be negative 20 multiplied by the distance, the perpendicular distance. From here to there, unfortunately, we don't know that distance. The only distance that we know, it is from point C to point A. It is given as 1 meter. Then allow me to denote the whole of this distance as y. Let's denote this distance as what? As distance y. It will be easy for us to calculate this unknown distance, y, or position. All right. Now, on this line, we are having an upward force, and the value of that force, it is 41,5. Then we are having a uniformly distributed load. Remember, we are having a uniformly distributed load. But now, where are we taking moment? We are taking moment here. Right. This is where we are taking moment. Now, we then have to convert this UDL. Now, allow me not to use this 5 here as we've converted from this point to that point. You can do it, but your work, it will be clumsy, it will have a lot of numbers, and it will be confusing for you. Always work smart, go for an easy way. Now, it then means I can then convert the UDL from this point to that point. Let's call this point point H. Okay? Now, I can then convert my UDL from point C to point H. And how do we convert a UDL to be a concentrated load? It is a 5 kilonewton per meter multiplied by the distance. Then we get what? A concentrated load. That is the same precision that we'll be using here as well. But now, take moment, bending moment at H, bending moment at H, it is what? It is 0. Right. If this is where we have taken moment, we are having 0 equals to, on this line, am I having a downward force or an upward force? We are having a downward force, and all forces going down, they are negative. I'm having negative multiplied by the distance from C to H, it is what? We don't know it, it is y, right? Now it will be negative 20 multiplied by y. Then you come and ask yourself, on this line, am I having a downward force or an upward force? We have an upward force, and the value of that force, it is 41,5. Now it will be plus 41,5 multiplied by the distance. The distance from here to there, we don't know it, okay? But we know that this distance from C to A, it is 1. Now, for us to be able to get this distance, remember, we denoted the distance from C to h as y. Now for us to get this distance, you will say y, the whole of y minus 1. When you are minusing y from y, you'll be left with that distance. Now it will be 41 y minus 1. Right. Plus, now we are having a UDL. We have to convert this UDL to be a concentrated load. Now it will be negative 5 multiplied by y, distance y. Right. This is the conversion of UDL to what? To concentrated load. Multiply by perpendicular distance. Perpendicular distance would be y divided by what? By 2. Because after you have converted this force, you need to put it at the center. The fact that we don't know the distance y, then it will be y divided by what? By 2. It's the same precision, good people. There's nothing has changed here. The thing is, we are having unknowns there, but we've been using the same principle. Then here it will be negative 20 y plus, we are removing the bracket, 41.5 multiplied by y, it will be 41.5 multiplied by y minus 41, 5, right, minus y multiplied by y, it will be y squared. It will be 5y squared divided by 2. When you divide 5 by 2, you will get 2, 5y squared equals to what? Equals to 0. Then we will be adding the like terms. When you add 41, 5 plus 20, you will have positive 21, 5 y minus 41, 5 minus 2, 5 y squared. We therefore have to rearrange our formula. After rearranging it, then we need to transpose it to the right hand side so that the coefficient of this, we need to arrange it in a ascending or descending order and transpose. When we are transposing 2, 5 to the left hand side, the sign will change. It will be 2, 5 y squared. When we are transposing 21.5 y to the left hand side, the sign will change. It will be negative 21.5 y. Transposing 41.5 to the other side, the sign will change, will be plus 41.5 equals to 0. Then from here, we will be using the quadratic formula in solving the y. Then y would be negative b plus or minus square root b squared 4ac divided by 2a. Our b, it is negative. Now negative multiplied by negative would be positive. We will write it as a positive sum there, value there, plus or minus square root. Then we are having 21.5 squared minus 4 times 2.5 multiplied by 41.5 41.5 divide by 2 times 2,5. Our y equals to, or y equals to. Now let's calculate it. I'm having 21,5 plus 21,5 squared minus 4 times 2,5 times 41,5 divide by 2 times 2,5. It is 21. Let's do it. Come on. I'm having 21,5 plus 21,5 squared minus 4 times 2,5 times 41,5 close bracket 2 times 2,5. Right. I get my answer, my y, as 5,675 meters, or my y is I get my y as 2,925. Now, the position of our BM from C to H, it is 2,95. We calculated it, the position from the left hand side. Now, from C to this one, let's denote this one as J, the point J. Now, we know that from C to D, the distance it is 5. That smaller portion from D to J, it will be what? 0,675. Now, our position, let's write it from C to H. From C to H, we got our answer is 2,925. Like I said, that they will direct you if you have to calculate the position from the left hand side or from the right hand side. But in this case, we calculated from the left hand side. Then the position from the left hand side to where J is, it is 5,675 meters. This is how you calculate your position where BM equals to 0, or calculating the position of the point of inflation. This is how you calculate them, good people. Thank you, good people.